You have 999 fair coins and one unfair coin with heads on both sides. You randomly select a coin and flip it 10 times. Each flip turns heads. What is the probability you chose the unfair coin? This problem has two cases. We either select the fair coin or the unfair coin. We could choose the fair coin with probability 999 thousandths, and the probability of observing 10 heads given that we've selected the fair coin is 1/2 to the 10th power. On the other hand, the probability of drawing the unfair coin is 1,000. However, given that we've drawn the unfair coin, the likelihood of observing 10 heads is exactly 1, because both sides of the coin are heads. This problem asks us to find a probability given some information. This is known as conditional probability, and conditional probability often implies the use of Bayes' rule. Bayes' rule is described as the probability of some event A given an event B is equal to the intersection of events A and B divided by the probability of event B. We can now restate the problem by saying that given that we've seen 10 heads, what's the probability that we flipped the unfair coin? And we can assign to event A selecting the unfair coin and to event B observing 10 heads. Formulating this problem accordingly, we can begin our calculation. The numerator asks us to solve for the intersection of events A and B. The probability of A and B reduces to the probability of A times the probability of B because each event occurs successively. From the table that we've drawn earlier, we know that the probability of selecting the unfair coin is 1,000, and the probability of observing 10 heads, given that we've seen the unfair coin, is exactly 1. Therefore, the numerator is equal to 1,000. To calculate the denominator, or the probability of observing 10 heads, we must partition across the two cases in which we can observe 10 heads. This is known as the law of total probability, and it asks us to compute the probability of observing 10 heads given that we've selected the unfair coin, and adding that to the probability of observing 10 heads given that we've selected the fair coin. Using the values from the table we derived in step 2, we get the probability of observing 10 heads as roughly 2,000ths. Combining terms, we can simplify our expression to 1,000 over roughly 2,000ths to get a probability of 0.506.